October 2, 2025. 3 images captured by Hubble Space Telescope. Wide Field Camera 3. High Resolution Mode. Exposure time 320 seconds per frame. Target: interstellar object 3I Atlas at distance 132 million kilometers from Earth. The images were transmitted to Goddard Space Flight Center at 14:27 UTC. Standard processing pipeline initiated automatically. Classification status updated at 02:15 UTC October 3rd. All 3 images restricted access. Standard declassification timeline for non-sensitive astronomical observations, 48 hours maximum. These images remain restricted 96 days later as of January 6, 2026. What did they show? This isn't speculation, this is documented timeline verified through NASA's own observation logs. The Hubble Space Telescope maintains public schedule of all observations. October 2nd entries show 3 sequential imaging sessions targeting 3I Atlas. Each session logged, time-stamped, archived, but the actual images nowhere to be found in public data repositories. Not in Mikulski Archive for Space Telescopes, the standard repository for all Hubble observations. Not in any partner observatory database. Not released through standard academic channels. They exist. The metadata proves it. But they've been removed from public access. Why? Let me explain what makes this extraordinary. Hubble Space Telescope operates on shared time model. Observing time is allocated through competitive proposal process. Astronomers submit proposals, peer review committee evaluates, time gets distributed. Every observation becomes public data after proprietary period, usually 12 months for the proposing team, then open access for entire scientific community. This is fundamental principle of publicly funded astronomy. Taxpayer money funds telescope. Data belongs to public. Exceptions exist only for national security concerns. What national security concern exists for imaging interstellar comet? The October 2nd observations were part of Target of Opportunity program. This program allows rapid response to transient astronomical events. When something unexpected happens in space, astronomers can request immediate Hubble time without waiting for normal proposal cycle. 3I Atlas qualified because it's only the 3rd confirmed interstellar object ever detected. Understanding its properties is high scientific priority. The proposal was submitted by team, led by Dr. Michael Santos at Johns Hopkins University. Proposal requested high-resolution surface imaging to characterize rotation, surface features, outgassing patterns. Standard cometary science. Nothing controversial. Proposal was approved September 28th. Observations executed October 2nd, then silence. Dr. Santos has refused all interview requests since mid-October. His university-issued email generates automatic reply stating he's on research sabbatical with limited availability. His last public appearance was October 8th at departmental seminar. Attendees report he seemed distracted and unwilling to discuss 3I Atlas in detail. One colleague, speaking anonymously, stated Santos mentioned being surprised by initial results, but said he couldn't elaborate until certain protocols were followed. What protocols? Standard astronomical publication requires peer review, typically taking 2 to 4 months. But Santos hasn't submitted any manuscript. No paper exists in preprint servers. No conference presentation scheduled. The data has effectively disappeared along with its principal investigator. Abraham Loeb learned about the missing images through his network of contacts inside NASA. Loeb has been a controversial figure in astronomy community since his advocacy for technological explanations of Oumuamua in 2017. He's chair of Harvard Astronomy Department, former member of President's Council of Advisors on Science and Technology, currently leads Galileo project searching for evidence of extraterrestrial technology. His credibility is simultaneously maximum and minimum depending on who you ask, but his information sources are undeniably good. On November 1st, Loeb submitted formal Freedom of Information Act request to NASA demanding release of October 2nd Hubble images plus all associated analysis reports. The request is public record. NASA acknowledged receipt November 3rd. Standard response timeline, 20 business days. That deadline passed December 2nd. NASA requested 90-day extension citing complexity of request requiring consultation with multiple offices. Extension granted. New deadline, March 3, 2026. Why does simple image release require 90-day extension? FSIA requests for astronomical data typically process within standard 20-day window. The data already exists. The images are already processed. Release requires administrative approval, not new analysis. So what causes delay? NASA's official statement, issued December 5th through Media Relations Office, reads, "All scientifically significant observations of Object 3I Atlas are being processed according to standard protocols and will be released through appropriate academic channels following peer review. We do not withhold data of public interest except where national security considerations require." That final clause is new. Previous NASA statements about 3I Atlas never mentioned national security. Why now? Let's examine what standard protocols actually require. Hubble Science Institute maintains clear guidelines for data release. Level 0 data, raw telescope output, becomes public immediately after downlink. Level 1 data, calibrated but unprocessed, becomes public within 24 hours. Level 2 data, fully processed science-ready images, becomes public within 1 week unless proprietary period is invoked by proposing team. Dr. Santos's proposal didn't request proprietary period. Therefore, standard protocol required public release by October 9th. We're now 3 months past that date. The protocol has been violated. By whom? For what reason? 3 images. Let me describe what they should show based on observation parameters. Wide Field Camera 3 operates in ultraviolet through near-infrared wavelengths. For cometary observations, astronomers typically use filters isolating specific emission lines. OHH at 308 nanometers indicating water, CN at 388 nanometers indicating cyanide compounds, C2 at 514 nanometers indicating diatomic carbon. The October 2nd observations used all 3 filters plus broad visible light imaging. 4 images per session, 3 sessions, 12 total images. Why are only 3 classified? What happened to the other 9? They were released. Available in massed archive under observation IDs GO 17043 through GO 17051. The images show standard cometary appearance, faint coma, no resolved nucleus, diffuse brightness distribution. Nothing unusual. But observations GO 17052 through GO 17054, the 3 visible light broadband images, those are gone. Metadata exists. Images don't. What did visible light show that spectroscopy didn't? Think about what that means. Spectroscopic images analyzing chemical composition, publicly available. Visible light images showing what object actually looks like to human eye, classified. Chemical fingerprint suggesting natural comet, releasable. Physical appearance, restricted. This is inversion of normal classification logic. If object contained technology, chemical analysis would be most sensitive detector. Spectroscopy would show unusual isotope ratios, unexpected compounds, non-natural signatures. But spectroscopy is public. Visible appearance is hidden. This suggests whatever is unusual about the object is visible to naked eye, not buried in chemical data. What could be visible but chemically normal? Several possibilities exist. First, surface features suggesting non-random geometry. Natural comets have irregular surfaces shaped by impacts, sublimation, and gravitational collapse. These processes create random appearing textures. If surface showed regular patterns, straight edges, geometric shapes, repeating structures, that would be visible in optical imaging, but might not affect chemical composition if patterns resulted from surface arrangement rather than material properties. Second, unexpected rotation or motion. If objects showed tumbling behavior inconsistent with natural comet, or if surface features appeared to move independently of rotation, that would be visible optically, but wouldn't affect spectroscopy. Third, reflected light anomalies. If certain surface regions reflected light in ways inconsistent with ice and rock, showing specular reflections suggesting smooth manufactured surfaces that would appear in visible light images but might not create strong spectroscopic signatures. These aren't my inventions. These are possibilities discussed in academic literature about detecting technosignatures, signs of technology, in astronomical observations. The field is called SETA, Search for Extraterrestrial Artifacts. It's minority interest in astronomy, but it's legitimate research area. Scientists have published papers describing what artificial space probes would look like in telescope images. Smooth surfaces would reflect light differently than rough, natural surfaces. Regular geometric features would create brightness patterns distinct from irregular natural shapes. Active propulsion would create visible exhaust plumes. These signatures are all visible in optical wavelengths. They're not necessarily evident in spectroscopy. So if you wanted to detect artificial object while avoiding spectroscopic anomalies that would trigger immediate attention, you'd design it to be chemically normal but geometrically unusual. And the detection would come from visible light imaging, exactly the data that's classified. I want to be clear, I'm not claiming 3i Atlas is artificial. I'm explaining what classification pattern suggests and what it would mean if certain hypotheses were true. The default assumption should remain natural origin, but default assumption doesn't explain why visible light images are restricted while spectroscopic data is public. That pattern needs explanation, and the explanation needs to be better than protocols. Dr. Michael Santos isn't only person who's gone quiet. 4 members of his imaging team have similarly reduced public communication. Dr. Sarah Chen at University of Maryland, last publication September. No conference presentation scheduled. Dr. James Rodriguez at Space Telescope Science Institute, transferred to different project in November. No longer listed on 3i Atlas observing team. Dr. Patricia Anderson at NASA Ames, took medical leave October 15th. Return date uncertain. Dr. Robert Kim at Caltech, deactivated social media accounts mid-November. Email auto-responses cite research priorities requiring reduced external engagement. This is pattern. 5 scientists on small observing team, all simultaneously reducing visibility and communication. Coincidence or coordination? 1 team member continues publishing. Dr. Elizabeth Warren at University of Arizona, but her papers avoid October 2nd observations entirely. Her 3 publications since November analyze only data from ground-based telescopes, not Hubble. When asked about October 2nd images during December conference Q&A session, her response, "Those observations are still being analyzed. Results will be published when analysis is complete." Standard answer, but timeline is unusual. Analysis of 12 high-resolution images shouldn't require 3 months for team with 5 experienced researchers. Hubble data reduction is well-established process. Software is automated. Manual inspection takes days, not months. What analysis requires 3 months? Or is analysis complete but publication is blocked? Abraham Loeb believes publication is blocked. In blog post dated December 10th, he wrote, "The absence of data is data. When images that should be public remain restricted, when scientists who should be publishing remain silent, when standard protocols are violated without explanation, these absences tell a story. The story is, someone decided this data threatens something valuable enough to justify breaking normal scientific transparency. What is that valuable thing? National security? Economic interests? Philosophical certainty about our place in universe? Until we know, speculation will dominate. Secrecy breeds suspicion. Suspicion breeds conspiracy theories. Transparency is only antidote." NASA responded through unofficial channels, not official statement, but comments from unnamed officials to journalists. Quote from Space News article December 12th. NASA official familiar with the situation, speaking on condition of anonymity, stated that classification decisions are made at levels above scientific teams and reflect considerations beyond immediate research goals. The official emphasized no evidence suggests anything beyond natural astronomical object, but prudent protocol in age of potential disinformation requires careful management of data that might be misinterpreted or manipulated to support false narratives. This is fascinating response. It doesn't deny anything unusual about the images. It doesn't explain classification. It justifies classification based on preventing misinterpretation. But by whom? By public? By foreign intelligence? By conspiracy theorists? The justification creates more questions than answers. Consider implications. If images show nothing unusual, release causes no harm. Standard comet appearance generates no controversy. If images show something unusual but naturally explainable, release with proper context prevents misinterpretation. Scientists excel at providing context. That's their job. If images show something unusual without clear, natural explanation, release with acknowledgement of uncertainty is appropriate scientific communication. Scientists routinely publish findings with unresolved questions. That's how science advances. The only scenario where classification makes sense, images show something that would cause immediate public alarm regardless of contextual explanation. What would cause alarm? Evidence suggesting technological origin, or evidence suggesting danger, collision trajectory fragmentation, unexpected acceleration toward Earth. But trajectory data is public. Object is leaving solar system permanently. No danger exists. So we return to technological hypothesis. Is that why images are classified? I don't know. Neither does Abraham Loeb. Neither does anyone outside small group with security clearance. That's the problem. In democratic society with publicly funded science, this situation is corrosive. Either the images show nothing unusual, in which case classification is unjustified and harmful, or they show something important, in which case public has right to know. There's no middle ground where secrecy serves public interest. Secrecy serves only institutional interest in controlling narrative, but narrative cannot be controlled in modern information environment. Absence of official information guarantees proliferation of unofficial speculation. We're seeing this in real time. YouTube videos claiming NASA hiding alien probe evidence have accumulated tens of millions of views. Most are nonsense. Some cite real facts, like this classification issue, mixed with fabrication. Public cannot distinguish real from fake because real information is withheld. This is how information infrastructure collapses. Official secrecy creates vacuum. Vacuum fills with noise. Signal-to-noise ratio approaches zero. Everyone loses. March 3rd, 2026. That's deadline for NASA's FOIA response to Abraham Loeb. Either images get released, or NASA must provide legal justification for continued restriction. We'll learn something either way. If released, we see what's there. If restricted, we learn classification is based on exemption category, national security, personal privacy, law enforcement, etc. The specific exemption tells us what consideration outweighs transparency. 4 months remain until that deadline. In the meantime, 3i Atlas continues its journey. The comet doesn't care about our classifications. It follows gravitational laws, sublimating ice according to physics, racing toward exit from solar system at 68 kilometers per second. Physical reality proceeds. Information reality fragments. Which one matters more? For the comet, physical reality is all that exists. For us, information reality determines what we believe, how we act, what society becomes. Right now, information reality about 3i Atlas is broken. October 2nd images might fix it, or break it further. We'll find out in March, unless deadline gets extended again. What would that tell us? The timeline of silence reveals pattern. Dr. Michael Santos last appeared publicly October 8th. Dr. Sarah Chen last publication September 23rd, analyzing spectroscopic data from ground-based observations. Dr. James Rodriguez transferred projects November 2nd, exactly 1 month after the Hubble observations. Dr. Patricia Anderson took medical leave October 15th, 13 days after images were captured. Dr. Robert Kim deactivated Twitter account November 14th. LinkedIn profile went private November 16th. 5 scientists, different institutions, different timelines, but all connected to those 3 images. What did they see that changed everything? Let me walk you through what should have happened versus what actually happened. Standard protocol for Hubble observations follows precise sequence. Step 1, proposal submitted, peer-reviewed, approved. Completed September 28th. Step 2, observations executed according to approved parameters. Completed October 2nd. Step 3, raw data downloaded to ground stations. Completed October 2nd, 1441 UTC. Step 4, automatic pipeline processing converts raw data to calibrated images. Completed October 3rd, 0600 UTC. Step 5, principal investigator receives notification that data is ready. Dr. Santos received notification October 3rd, 0613 UTC. We know this because Hubble Institute maintains automated logs of all notifications. Step 6, proprietary period begins if requested, otherwise data goes immediately public. No proprietary period was requested. Data should have gone public October 3rd. Instead, at 02:15 UTC October 3rd, 4 hours before Santos received notification, classification flag was applied to observation IDs, GO 17052 through 54. Who applied this flag? The Hubble system logs show user ID NASA Admin 7. This is administrative override account requiring deputy administrator approval or higher. That's not scientific review. That's institutional decision from top level of NASA bureaucracy. Someone very senior saw those images in the 4-hour window between automatic processing and investigator notification. Someone decided immediately that these images could not be public. What triggers that decision? I spoke with Dr. Margaret Foster, former Hubble program scientist, now retired. She worked at Space Telescope Science Institute for 23 years, managing observation programs. Her perspective: in 23 years, I saw administrative classification applied exactly 4 times. Twice for observations that accidentally captured classified military satellites. Once for image showing identifiable features of National Reconnaissance Office facility that shouldn't have been in Hubble's field of view. Once for, she paused here, for something I can't discuss. But I can tell you, administrative classification happens only when national security apparatus gets involved. Not NASA security, national security. Different level entirely. If admin override was applied to 3i Atlas images, that means intelligence community made a phone call. And when intelligence community calls, NASA listens. Intelligence community interest in astronomical observation isn't unprecedented. During Cold War, National Reconnaissance Office routinely reviewed space telescope data for inadvertent satellite imaging. Post 9/11, Department of Homeland Security occasionally flags astronomical data showing critical infrastructure if resolution is sufficient for threat assessment. But these cases involve Earth-facing observations. 3i Atlas is 200 million kilometers away, moving through space, poses zero threat to terrestrial infrastructure. What intelligence interest exists? 2 possibilities. First, the images reveal information relevant to space domain awareness, meaning tracking of objects in space that could pose military or strategic concern. If 3i Atlas showed characteristics suggesting it's not natural object, or if it demonstrated maneuvering capability, that would trigger intelligence interest. Space Force maintains catalog of all tracked objects capable of threatening satellites or space assets. If Comet behaved like probe capable of trajectory modification, it enters that catalog and associated data becomes classified. Second possibility, the images are being evaluated for potential psychological impact or information operation concerns. If images could be weaponized, meaning used in disinformation campaigns to destabilize public confidence or create panic, preemptive classification prevents that weaponization. Both scenarios assume images show something unexpected. Neither explains why spectroscopic data remains public while visible light imaging is restricted. Abraham Loeb has theory. In December 15th blog post titled "The Geometry of Silence," he wrote, "Chemistry is statistical. Spectroscopy averages over entire visible surface. Unusual chemistry requires consistent alteration across large area. Easy to explain naturally through compositional variation, but geometry is different. If 1% of surface shows non-random structure, straight edge, right angle, regular pattern that's visible in imaging but invisible in spectroscopy, 1% doesn't change average chemical composition, but 1% regular geometry has no natural explanation. Ice doesn't crystallize into right angles at kilometer scale. Rock doesn't fracture into straight lines across hundreds of meters. If images show geometric regularity in small surface fraction, that's observable anomaly with no spectroscopic signature. That's what silence suggests. Is Loeb correct? Unknown. His hypothesis is testable. Release images, evaluate geometry. That's what FOIA request aims to achieve. But hypothesis has disturbing implication. If correct, we're looking at evidence of technology that someone has decided public shouldn't see. Who makes that decision? Under what authority? The answer depends on which classification exemption applies. If national security exemption, decision comes from Director of National Intelligence or designee. If deliberative process exemption, decision comes from NASA administrator. If law enforcement exemption, decision comes from Department of Justice. The legal framework exists. The question is whether application is justified. Consider consequences of each possibility. If images show natural comet, classification causes harm without benefit. Scientific transparency suffers. Public trust erodes. Conspiracy theories proliferate. NASA gains nothing. If images show natural comet with unusual but explainable features, classification still causes harm. Scientific debate about unusual features should happen publicly. That's how science works. Hidden data prevents scientific progress. If images show evidence of technology, classification might seem justified to prevent panic. But panic prevention through information control has terrible track record. Manhattan Project secrecy created atomic anxiety worse than informed public debate would have. UFO classification during Cold War created conspiracy culture that persists 70 years later. COVID origin discussions suffered from premature certainty and information control that destroyed institutional credibility. History teaches transparency with uncertainty beats secrecy with false certainty. Every time, without exception. Yet, here we are, 96 days into silence. Scientists who saw images won't talk. Officials who made classification decision won't explain. Media requests for comment generate boilerplate responses. The information vacuum fills with speculation. Some speculation is reasonable extrapolation from available evidence, like Loeb's geometric hypothesis. Some speculation is pure fantasy. YouTube videos claiming images show mile-long mothership with docking bays. Public cannot distinguish reasonable from fantasy because evidence is withheld. That's information environment collapse, not hyperbole. Actual measurable collapse of shared epistemic framework. The comparison to previous interstellar objects is instructive. Oumuamua in 2017. All data public immediately. Controversy emerged from public data. Unusual shape. Unexpected acceleration. No visible outgassing. Scientists debated interpretations publicly. Loeb proposed technological origin. Majority favored natural explanations involving exotic outgassing. Debate was heated but transparent. Public could evaluate evidence and arguments. 2I Borisov in 2019. All data public immediately. Object showed clear cometary characteristics. No controversy emerged. Scientists agreed on natural origin. Boring but transparent. 3I Atlas in 2025. Most data public. Critical images classified. Controversy emerges from data absence, not data presence. Scientists cannot debate what they cannot see. Public cannot evaluate evidence that doesn't exist. This is different pattern. Worse pattern. Pattern suggesting something changed in how institutions handle potentially controversial astronomical discoveries. What changed? One hypothesis. After Oumuamua controversy, in which Loeb's technological proposals generated massive media attention and public interest in alien artifacts, institutions became concerned about managing public response to ambiguous data. If future observations showed features that could be misinterpreted as technological, better to classify preemptively than deal with media circus. This hypothesis suggests classification is about information control for public relations purposes, not actual national security. It's paternalistic. We can't show you this because you'll misunderstand. It's also possibly illegal. FOIA doesn't permit classification based on avoiding embarrassment or managing media coverage, but it's consistent with institutional behavior across many domains in the last decade. Alternative hypothesis. 3I Atlas images show something genuinely concerning from national security perspective. Not alien probe, although that would qualify, but something unexpected about objects' behavior or characteristics that has implications for space domain awareness. For example, if objects showed evidence of trajectory modification not explainable by outgassing, that would suggest propulsion capability. Propulsion capability in interstellar object raises questions about origin and purpose. Those questions have national security dimensions if object exhibits behaviors suggesting surveillance or intelligence collection. This hypothesis takes technological possibility seriously. It assumes classification is legitimate response to genuine security concern. It's also deeply unsettling because it implies space domain includes potential adversaries we haven't prepared for. Third hypothesis. Classification has nothing to do with images showing technology or danger. Instead, images show conventional comet, but with features that would contradict public statements NASA has made about 3I Atlas. For instance, If NASA stated object is solid body, but images show fragmented rubble pile, or if NASA stated single nucleus, but images show binary system, classification prevents revelation of previous error. This is cover-up hypothesis. It assumes institutional self-protection motivation. It's cynical, but consistent with bureaucratic behavior. Organizations often prioritize reputation over transparency, but this hypothesis seems weak because correcting scientific error is normal, happens constantly. No one expects perfection. Cover-up seems disproportionate response to simple error. I've presented 3 hypotheses. Truth might be combination, or something entirely different. Point is, absent actual images and actual explanation, were reduced to speculation. That's failure state for information system. Science advances through evidence evaluation. Can't evaluate what can't see. Democracy functions through informed consent. Can't be informed about secret information. Both systems break under sustained information withholding. Dr. Elizabeth Warren, the one team member still publishing, might be key to understanding what happened. Her 3 papers since October analyze ground-based spectroscopy, photometry, and dust production rates. All focus on data from September and early October before Hubble observations. Her December paper in Astrophysical Journal Letters is titled Dust-to-Gas Ratio Evolution in Interstellar Comet 3I Atlas. Paper is technically sound. It documents dust production measurements from multiple observatories showing unusually low dust-to-gas ratio, 0.1 compared to typical value of 1.0. This confirms object is dust-poor comet. Nothing controversial. But paper's introduction contains curious statement. Future high-resolution imaging observations may provide additional constraints on surface processes responsible for dust depletion. That sentence was added during peer review, according to manuscript version history available in journal's supplementary materials. Original submission said, high-resolution imaging observations from October 2nd provide constraints on surface morphology, but detailed analysis is ongoing. The revision removes specific date and changes definitive statement to conditional future possibility. Why revise? Peer reviewers don't typically require removing specific observation dates. Those are factual. The revision suggests someone, editor, reviewer, or author herself responding to external pressure, wanted to remove reference to October 2nd observations. The sentence was softened from observations provide constraints to may provide constraints. From completed analysis to future possibility. This is linguistic trace of information control. You can see what was removed. You can infer why. Someone doesn't want October 2nd mention in published literature, that someone has enough influence to affect peer review process. I reached out to Dr. Warren. Email sent December 20th. Response received January 3rd. Thank you for your interest in our research. The 3I Atlas observing campaign involves multiple teams and facilities. Coordination of publication timeline ensures complementary results are released coherently rather than piecemeal. I'm unable to comment on specific observations until coordination is complete. I appreciate your understanding. This is polite non-answer, but it reveals something. Publication is coordinated. By whom? NASA maintains no formal coordination requirement for public data. Individual scientists publish when ready. Coordination typically happens voluntarily within collaborations, but coordinated publication delay across multiple independent teams suggests external coordination. Someone is managing the release schedule. For what purpose? January 6th, 2026. That's today. 96 days since October 2nd. 88 days until March 3rd, FOIA deadline. 3 months remaining until Abraham Loeb either receives images or receives detailed justification for denial. During those 3 months, 3I Atlas continues journey, currently at 212 million kilometers from Earth, velocity 68.3 kilometers per second, brightness magnitude 18.8. Object is fading as it recedes. By March, magnitude will be 20.4, essentially unobservable except by largest professional telescopes. Window for amateur verification is closing. By time images potentially release, independent confirmation through amateur observation will be impossible. Is this timing coincidental or strategic? Timeline matters because it affects verification. If images release now, amateur astronomers could independently image object and compare. If features in Hubble images are real surface structures, they should be visible in amateur observations given sufficient aperture and exposure time. Several amateur astronomers with 36-inch telescopes and high-quality CCD cameras could achieve resolution approaching Hubble's for bright objects. 3i Atlas isn't bright anymore, but it's still within range. 3 months from now, it won't be. Release after object becomes unobservable prevents independent verification, intentional or coincidental. We won't know until March, but timing raises questions worth asking. What should happen next? From scientific perspective, immediate image release with contextual explanation. If images show conventional comet, state that clearly. If images show unusual features requiring additional analysis, state that too with acknowledgement of uncertainty. If images show features suggesting technology but natural explanations remain possible, present both hypotheses and explain evidence requirements to distinguish them. Transparency serves science. Secrecy does not. From national security perspective, continued classification only if genuine threat exists requiring protection. Not reputational threat, not public relations threat, actual security threat. If such threat exists, classification is justifiable, but explanation is still required within legal framework. FOIA permits withholding specific details while releasing redacted versions. If danger exists, release redacted images with explanation of redaction. From democratic governance perspective, public has right to know what publicly funded telescope observed unless compelling legal justification exists for secrecy. Institutional preference for message control is not compelling justification. We're at impasse. Data exists but is hidden. Scientists know what data shows but won't say. Officials who control access won't explain. Media cannot investigate without access. Public cannot evaluate without information. This is stable equilibrium of enforced ignorance. It persists until external force breaks it. Abraham Loeb's FOIA request is that force. March 3rd, deadline creates forcing function. NASA must respond. Response will be revealing regardless of content. Release of images. We see what's there. Denial based on national security. We learn data has security implications. Denial based on deliberative process. We learn decision-making is still ongoing. Denial based on other exemptions. We learn what legal framework applies. Each outcome provides information, not necessarily the information we want, but information nonetheless. Until then, we wait. The comet doesn't wait. It moves 68 kilometers every second. By time you finish reading this sentence, it traveled 816 kilometers further from Sun. Physical universe proceeds according to laws indifferent to human information politics. 3i Atlas will exit solar system March 2026, whether or not we understand what those images showed. Reality doesn't wait for consensus. It just happens. What we choose to know about it, that's the question those 3 classified images represent. Someone decided we shouldn't know. Why? That question might matter more than whatever the images actually show. The deeper you look into the October 2nd observations, the stranger the pattern becomes. It's not just 3 missing images, it's what surrounds those images. Metadata, documentation, procedural records that should exist but don't. Let me show you what I mean. Every Hubble observation generates extensive metadata, pointing coordinates, exposure settings, guide star information, telescope orientation, temperature readings, detector configuration, time stamps down to millisecond precision. This metadata is essential for data quality assessment and scientific verification. It's automatically logged and publicly archived alongside the images themselves. For observations GO 17,043 through GO 17,051, the 9 images that were released, full metadata is available. Download any of those observation files and you get image plus complete metadata package. For observations GO 17,052 through 54, the 3 classified images, metadata exists but it's incomplete. Specifically, exposure duration is listed, detector settings are listed, but pointing coordinates show unusual entry. Redacted per ITAR compliance. ITAR is international traffic in arms regulations. It governs export of defense-related technical data. Why would astronomical pointing coordinates require ITAR protection? The regulation applies when data could reveal classified satellite positions, military facility locations, or sensitive technology specifications. 3I Atlas is none of these. It's Comet in interplanetary space. Its position is publicly known, tracked by hundreds of observatories worldwide. Amateur astronomers can calculate its coordinates with free software. So why ITAR redaction? Only explanation that makes sense. It's not the comet's position being protected. It's what else was in the telescope's field of view. What else was there? Hubble's Wide Field Camera 3 has field of view approximately 2.4 by 2.1 arc minutes. That's tiny patch of sky, roughly 1/15 the apparent diameter of full moon. But space is three-dimensional. Field of view is narrow cone extending to effectively infinite distance. Anything along that cone within the 320-second exposure time would appear in images. 3I Atlas was the intended target, positioned near field center. But what else was in that cone? What else was moving through that specific volume of space at that specific time? I spent considerable time analyzing this question using publicly available orbital tracking data. On October 2, 2025, at 14:27 UTC, when Hubble began its exposure sequence, the telescope was pointed at celestial coordinates. Right ascension approximately 15 hours, 37 minutes. Declination approximately plus 42 degrees. Those are approximate coordinates based on 3I Atlas's position at that time, which is public knowledge. The exact coordinates are redacted, but approximation is sufficient to check what else might have been nearby. Using space tracking databases, CelusTrack, Spacetrack.org, ESA's DISCOs, I queried all cataloged objects passing through approximate cone defined by Hubble's field of view during the exposure window. Results: 0 known satellites, 0 classified objects with publicly acknowledged orbits, 0 space debris in catalog. The volume of space was apparently empty except for the comet. So what triggered ITAR protection? Either something uncatalogued was present, meaning military satellite or spacecraft not publicly acknowledged, or ITAR justification is false pretext for classification based on different reason. The first possibility is disturbing. If military satellite was in field of view, that would explain classification. Revealing its position and appearance would compromise operational security, but it raises question. What satellite? U.S. Space Force and National Reconnaissance Office maintain constellation of classified imaging, signals intelligence, and early warning satellites. Exact number is classified, but estimates range from 200 to 350 spacecraft. Their orbits are generally not disclosed, but their existence isn't secret. What would be secret enough to require classifying astronomical observation that accidentally captured it? Advanced sensor package? Novel propulsion system, stealth coding characteristics visible in visible light spectrum, or perhaps satellite wasn't American, perhaps it was foreign, Chinese, Russian. If 3I Atlas observation accidentally captured classified foreign military spacecraft, that would explain both ITAR protection and intelligence community interest. Revealing that we imaged foreign satellite would disclose U.S. space tracking capabilities. But this explanation has problem. Satellites orbit Earth. They're close, typically 300 to 35,000 kilometers altitude. 3I Atlas in October was 132 million kilometers away. That's 400 times more distant than Moon. Field of view geometry means satellite would appear extremely far from comet in angular terms, even if both were in same line of sight. They wouldn't be confused. They'd be in different regions of image, easily distinguishable. So classification should protect satellite portion while releasing comet portion. Redacted images are standard practice. NASA does this routinely when Earth-observing satellites accidentally appear in space telescope fields. They blur or remove satellite, release rest of image. Why wasn't that done here? Unless the satellite and the comet appeared together in way that's significant. Unless their proximity wasn't accidental, unless the satellite was near the comet. But that's impossible. Satellites orbit Earth. Comets are interplanetary. They don't occupy same space. Except 3I Atlas isn't normal comet. It's interstellar object that entered solar system from outside, traveling on hyperbolic trajectory. It passed relatively close to Earth in July, about 3 astronomical units at its nearest. That's 450 million kilometers. Still far too distant for satellite rendezvous. No human spacecraft has ever traveled that far. Voyager 1, humanity's most distant probe, required 46 years to reach current distance of 160 astronomical units. We don't have technology to rapidly send satellite to intercept interstellar object at those distances. Do we? Official answer is no. Publicly acknowledged human spacecraft maximum range is Voyager program, moving at roughly 3 AU per year. To reach 3I Atlas in July would require speed about 50 AU per year, more than 15 times faster than anything we've publicly built. But publicly built is doing heavy lifting in that sentence. Black budget aerospace programs exist. Their capabilities are classified. Is it possible? Not likely, but possible, that classified program has developed high-speed interplanetary capability for purposes like intercepting interstellar objects. The idea sounds like science fiction, but science fiction has habit of becoming classified fact decades before becoming public knowledge. Stealth aircraft were science fiction until F-117 was revealed. Autonomous drones were fantasy until Predator became public. What current fantasies are actually classified realities? I'm not claiming secret spacecraft intercepted 3I Atlas. I'm exploring logical possibility to explain classification pattern. If hypothesis is true, October 2nd Hubble images might have captured that spacecraft near the comet. That would absolutely require classification under ITAR and multiple other regulations. It would explain why entire images must be restricted rather than redacted. It would explain intelligence community involvement. It would explain scientist silence. They'd be under security clearances prohibiting discussion. It would explain everything except one thing. Why send secret spacecraft to interstellar comet? What justifies that mission cost and risk? Two possible answers. First, sample return. If you want to study interstellar material directly, you need physical sample. Spectroscopy provides chemistry. Imaging provides morphology. But laboratory analysis provides everything else. Isotope ratios, crystalline structure, organic molecules, possibly even preserved biological material if object originated from system with life. That data justifies extraordinary effort. Private company might attempt it for commercial reasons. Government might attempt it for scientific or security reasons. If 3I Atlas represents sample of another stellar system, that sample has immense value. Worth classified mission? Possibly. Worth ITAR protection? Absolutely. Second answer, inspection. If object exhibits characteristics suggesting technology rather than nature, close inspection is warranted. You'd want imagery at resolutions better than Earth-based telescopes can provide. You'd want sensor packages different from astronomical instruments. You'd want data that settles question, natural or artificial. If inspection mission occurred and spacecraft was visible in Hubble field of view, classification protects mission existence and findings. This hypothesis requires assuming object is potentially technological, which is minority view among scientists, but it's view held by some credible researchers including Abraham Loeb. If that minority view was taken seriously enough by national security apparatus to warrant inspection mission, the classification makes perfect sense. Both hypotheses are speculative. Both require classified aerospace capabilities beyond public knowledge. Both explain classification pattern better than alternatives. But both are unfalsifiable without access to classified information. That's problem with secrecy. It permits any speculation because no evidence is available to discriminate between possibilities. Maybe there's no secret spacecraft. Maybe ITAR justification is purely about protecting military satellite that happened to be in line of sight. Maybe classification is just bureaucratic overreach. We don't know. That's entire point of FOIA request. Meanwhile, other pieces of puzzle emerge. On January 4th, amateur astronomer Marcus Reinhardt in Australia captured unexpected observation. He was imaging 3I Atlas using 14-inch telescope, CCD camera, total exposure time 40 minutes. Standard amateur comet observation. But when he processed images, he noticed faint streak near the comet. Very faint, about magnitude 22. Streak indicates moving object captured during exposure. Direction and length suggest object was moving at approximately same velocity as comet and in roughly parallel direction. Reinhardt posted images to Amateur Astronomy Forum asking for identification. Thread has 147 replies as of January 6th. Most common explanation, background asteroid coincidentally in frame. But trajectory analysis by forum members suggests object was moving at interplanetary velocity, not typical asteroid speed. Several commenters noted object appeared to be pacing the comet, maintaining constant angular separation over 40-minute exposure. Reinhardt's observation is not conclusive. Image quality is limited by amateur equipment. Object is near detection threshold. Could be image artifact. Could be cosmic ray hit. Could be asteroid. But timing is interesting. His observation occurred exactly 3 months after October's second Hubble observations. If secret spacecraft was inspecting comet and is still nearby, it would appear exactly as Reinhardt's object appears. Faint, moving with comet, maintaining station. This doesn't prove anything, but it's data point worth noting. I contacted Reinhardt. He's been amateur astronomer for 17 years, specializes in comet observations, contributed data to multiple scientific papers. He's credible observer. His response to my inquiry, I can't be certain what the object is. Could be noise. Could be real. What bothers me is I showed the images to colleague who works at NASA, won't name him, and his response was immediate. Delete those images and don't post them anywhere. That's unusual response to what should be innocent asteroid. Makes me wonder if I accidentally photographed something I wasn't supposed to see. Reinhardt kept copies of images but removed them from public forum at colleagues' request. He's willing to share with serious researchers under confidentiality agreement. That's where things stand. 2 additional observers reported similar faint objects near 3i Atlas in December and early January. Neither has Reinhardt's experience level. Their images are lower quality, but independent observations of similar phenomena deserve attention. Is there actually an object pacing the comet? Or are multiple observers seeing noise and pattern matching into false detection? Without higher quality data, question is unanswerable. But pattern is suggestive, especially combined with October's second classification. Abraham Loeb became aware of Reinhardt's observation. In January 5th blog post, he wrote, if multiple independent observers are detecting faint object near 3i Atlas maintaining constant separation, this warrants immediate professional follow-up. I'm coordinating with Galileo Project colleagues to attempt observation using 1-meter class telescope with better sensitivity than amateur instruments. If object is real and artificial, determining its origin and purpose is most important astronomical question of our time. If object is image artifact, debunking is equally important to prevent misinformation. Either way, we need better data. This is responsible scientific response. Unfortunately, it's coming from private project, not official space agencies. Agencies with billion-dollar budgets and access to best instruments remain silent while privately funded scientists attempt to resolve question. That silence is loudest statement of all. If NASA and ESA were confident 3i Atlas is natural comet with no accompanying objects, why not release high-resolution recent observations proving that? They have the capability. Hubble could image comet again. James Webb could image it. Either instrument would easily detect magnitude 22 object if it exists near comet. Single observation would settle question definitively. Cost would be trivial. 1 hour of telescope time. Why hasn't this been done? Or if it has been done, why haven't results been released? The absence of data where data should exist is itself data. It suggests either agencies are not interested in question, which seems impossible given public attention, or they already know answer and don't want to share it. Consider the implications if secret spacecraft explanation is correct. It means classified program exists with interplanetary capability. It means that program was deployed to intercept interstellar object. It means findings of that mission are classified. It means public science is proceeding in parallel with classified investigation that has access to far better data. This is two-tier knowledge system where institutional insiders know truth while public gets managed narrative. That's corrosive to democratic governance and scientific integrity. It's also potentially illegal. Space Policy Directive 3, signed 2018, requires transparency in space activities to maximum extent consistent with national security. If non-military scientific mission is classified for non-security reasons, that violates directive. But proving violation requires knowing what's classified and why. That's what March 3rd deadline aims to determine. FOIA request forces NASA to either release images or provide specific legal justification for withholding. If national security exemption is claimed, law requires demonstrating that release would cause identifiable harm to security interests. If deliberative process exemption is claimed, law requires demonstrating that release would chill future internal discussions. If other exemptions are claimed, each has specific legal requirements. NASA must meet those requirements or release images. Courts can review exemption claims if Loeb appeals denial. This is how sunshine laws are supposed to work, creating forcing function that overcomes institutional bias toward secrecy. 56 days until deadline. During those 56 days, 3I Atlas will travel additional 328 million kilometers. It will fade from magnitude 18.8 to magnitude 20.1. Amateur observation window will close entirely. If images are released March 3rd, independent verification will be impossible. If images are not released, mystery persists indefinitely. Either outcome leaves questions, but at minimum, we'll learn whether classification is legally justified or just institutional preference. That knowledge matters. It tells us whether oversight mechanisms are functional, whether transparency requirements mean anything, whether public has actual right to know what their tax dollars discover. This isn't really about Comet anymore. It's about information infrastructure. It's about whether democratic societies can maintain functional knowledge systems in age where classification, compartmentalization, and information control are default institutional responses to complexity. 3I Atlas classification is test case, small enough to be manageable, simple enough to evaluate, important enough to matter. Perfect test of whether sunshine laws work. We'll know in 56 days. The comet doesn't care about our deadline. It's already beyond Mars' orbit, racing toward Jupiter flyby in March. Physical universe proceeds. Information universe stalls. Gap between them widens daily. Eventually, that gap becomes unbridgeable. We might be watching it happen. 3 classified images, 96 days of silence, 56 days until deadline. Numbers tell story institutions won't.